Okay, so in this video, we're going to talk about states of matter and their changes. Okay, and so matter exists primarily in three phases or three states. Okay, and these states are solid, liquid, and gas. Now, the state that matter will be in, or the phase, depends on the relative strength of the attractive forces between the molecules or between the particles themselves, and compared with the amount of kinetic energy that the particles may have. Now, of course, when it comes to state of matter, one of the things that is often talked about is the changes between the state or the phase changes. Okay, and so let's just for purpose of labeling this, right? So the phase change between solid to liquid is called melting. Okay, solid to melt into liquid. The phase change from a liquid to a gas, there's several. Oftentimes you say it's boiling or vaporization is another one. Okay, same thing. Going from a gas to a liquid is condensation. Okay, and then going from a liquid to a solid is freezing. Another technical term to this is fusion. Okay, so these are the terms as for going from solid liquid to gas, gas liquid to solid. Also, there's a term for when the solid becomes a gas, skipping the liquid stage. All right, this is sublimation. All right, and then from a gas back to a solid, skipping the liquid state, this is deposition. Okay, so these are the labeling of the different phase changes. Now, recall the phase changes themselves are completely reversible. All right, and so you could have something like a solid, like let's do something. Let's talk about this scenario that we all know of, where we may have ice, and we know that we could definitely melt the ice into its liquid state, right? Either by you could heat it up by your hand or leave it outside of room temperature. Solid ice will melt into liquid water. All right, and then if you choose to boil the water, then you could get the water to become steam, a gas version of water. Now you could go the opposite direction. You could take the steam and cool it down to become liquid water, and then you could put the water into a freezer, and then it could become solid ice again. So it's completely reversible. All right, so it doesn't mean that when you get a substance to be one phase to another that you cannot we cannot get it back to the original state of matter. Okay, so now there are two things that affects phases of matter, or there are two things that characterize, and these two things, when they change them, you're allowing phases of matter to take place. And the two things I'm talking about is enthalpy and entropy. Okay, and so let's go ahead and describe exactly what they are. All right, so enthalpy essentially is a measure of heat absorbed or released during any process. All right, so it could be a chemical process, or it could be a physical process. Since we're talking about states of matter, phase changes, these are just all physical processes. All right. Enthalpy is signified by H. So H means enthalpy. Now, it's impossible. So when you think about enthalpy, another way you can kind of think about enthalpy is how much energy that particular substance have. Now, it's almost impossible for us to measure how much energy something has, but we can measure the changes of energy, if it gained or it lost energy. And so this, we often call it delta H, or delta enthalpy. All right, because we can measure how much energy something has gained or something has lost. Okay, so we often see as a delta H or a delta enthalpy. All right. And to go in a little bit more detail, so, and oftentimes this comes in two forms. Either you have a negative delta H or a positive delta H. All right. Negative delta H simply means that the substance undergone an exothermic process. An exothermic process simply means that it lost energy. Okay. So exo, exiting, thermic, heat, or energy in itself. All right, so if you see a negative delta H, that means it lost energy. Okay, it released energy. A positive delta H simply means that that substance undergone an endothermic process, or it gained energy. All right, so energy was put into it. All right. And so it gained energy. All right. So how does that relate to the state of matter that we were talking about earlier? Well, let's kind of go back to this. Okay. So remember, it's all about gaining energy or losing energy in terms of enthalpy, right? If it's something's endothermic or exothermic. Well, when you're melting something, all right, when you're melting something, for example, ice, you have to give ice energy for it to melt. All right, so you sense like the palm of your hands. If you're holding ice with the palm of your hands, and your hands is basically more hotter, right? It has more energy, so energy always flow. And I'm kind of write this off to the side. And so this is what we call heat. All right, and so heat flow is basically where energy always flow, and it always flows this way. Energy flow from where is more energetic or more hotter to less energetic. All right, so heat always flow, or energy always flow from where it's hotter, from where it has more energy to where there is less energy, or from hotter to colder. All right, and so if you're holding ice in your hands, the heat from your hands, or the energy from your hands, is going to be transferred into the ice, because your hands it's warmer, it has a higher temperature than the ice, right? And so then this process is endothermic. All right, you got to give it energy in order for it to go from a solid state to a liquid state. Same thing that you can imagine if we're like melting some type of metal, right? Oftentimes you see that they're adding a lot of energy. They put in some type of furnace, oven, whatever the case may be, in order to have that metal to melt. Okay, and the same idea when you're boiling or vaporizing something. And so when you're boiling or vaporizing, you will put like water on the stove. You're trying to cook and you're trying to heat up the water. Oftentimes, if you heat up the water hot enough, then you start seeing bubbles, right? It's boiling, okay? And so as it's boiling, this is indication that this is also an endothermic process, because you're giving it energy, all right, in order for it to boil, all right, in order for it to evaporate, all right. Sublimation is the same way. You're going from solid state to gas state. So this is also an endothermic process, all right. So all these have a positive delta H, all right, because you have to give it energy in order for this to take place, all right. There's an increase of that substance within that thing, right? Now, if you're going the opposite direction, you're going from gas to liquid or liquid to solid, you have to pull energy away from it, all right? And so this right here is an exothermic process, all right? Or will have a negative delta H, meaning that it lost energy. Okay, when you put something into a freezer, like water into a freezer, and you want it to become ice, essentially what you're doing is that you're trying to strip the water away from, try to strip the water of its energy. And when you do that, you're decreasing the the amount of energy it has, and thus it will solidify. All right. And so this right here, we say that it's also exothermic. All right. And deposition also same way, is a negative delta H, and it's also an exothermic process. So anything that loses energy will be exothermic. Anything that gains energy or absorbs energy will be endothermic. Now let's talk about entropy, all right, and how that relates to what we're talking about. So entropy, okay, or we symbolize this as an S, okay, is a measure of the change in molecular disorder or freedom that occurs or during a process. All right, so what does this mean? Entropy is basically the measure of disorder. All right, in all short list of terms, it's a measurement of disorder. So how organized or how disorganized something may be, it's a matter of entropy, right? And so you can kind of think about this. As I said, it's also very difficult to measure disorder, but we can measure the changes of entropy, okay? And so we always look at delta S, all right? So delta S is their change in entropy, okay? And much like always, if you have a positive delta S, that simply means you have more, or it has been more disordered, all right? It's more chaotic. And if you see a negative delta S, it's more orderly, all right? So what does that mean, right? So if you think about your own bedroom or your own house, depending on your living situations, and we could oftentimes say that generally some teenagers their room has high entropy, or that means is very disordered. Okay, it's very chaotic. There's clothes everywhere. There's food under the bed. Stuff like that. And then you may have some people where their house or their rooms have very low entropy. It's very orderly, very organized. All right, there's less chaos. So that's the thing with entropy. Okay. So how does that relate to what we're talking about in terms of states of matter? Well, if you think about what the particles are going through, then you could kind of figure out the changes of entropy, whether it'll be a positive delta S or a negative delta S, right? And so if you're going from a solid state to liquid state, and just kind of see what happens. Solids, the particles are very organized, all right? There's very strong forces that keeps them bonded together in a very rigid state. All right, you give it enough energy, and then now at the liquid state, you will see that the particles are able to move around. They're able to flow. There's no definite shape. And so because of this, when you're melting something, all right, you are actually increasing the entropy. It's becoming more disorderly, all right? And when you are boiling something, it's the same thing, all right? It's becoming more disorderly, all right? Or when you're boiling something, evaporating, vaporization, it's becoming a gas. Particles are everywhere. It's going in all sorts of random different directions. So it's becoming, that particle, that substance becoming more disorderly. It's not as organized as it used to be, okay? But then when you go in the opposite direction, all right, you will see that it's becoming less disordered or less chaotic. So going from a gas where the particles are anywhere in any random direction to a liquid where there is a definite volume, not necessarily definitely shape, we could all agree that it's becoming more orderly, or you have a negative entropy because it's becoming more orderly. All right. And it's the same idea when the liquid becomes a gas where it has a definite shape, the particles are tightly together due to strong forces between them, and it's in a rigid shape, it's in this particular shape, it's definitely very so much so orderly. So it also, this phase change also is a negative delta S, all right, going from a liquid to the gas state. All right, and this is also true for deposition, which is a negative delta S. And then for sublimation, since you're becoming extremely disordered, it's a positive delta S. All right, and so that's how order or entropy affects the phases of matter.